Hi everyone! This tutorial will teach you how to display a fireworks effect on the screen using a shader, which can be a nice reward after successfully completing a level in your game. Let's get started. We'll start as usual by creating a 2D scene, which we'll name Fireworks TSCN. Let's do it right here. Create new scene, 2D, Fireworks. Okay. And we'll add a color rect as a child node. Child node color rect. Let's set the usual dimensions to 600 by 400 in layout, transform and size. Okay, and scroll down to the material, create new shader material, click add new shader, and it should be canvas item type, and we will put it to the folder shaders. Open, create, and click to open in the editor. Let's expand this one, and we'll prepare the skeleton of our algorithm. Since we'll be only needing the fragment function, we can delete the rest. So vertex would go away and light can be deleted as well. Okay, let's start with fixing the resolution and aspect ratio. Uniform vec2 resolution is just like in our previous videos. It would be equivalent to our current dimensions of the color rect, 600 and 400. Okay, and we will use it in the fragment function. First, let's define UV as the UV coordinates shifted to the center, minus 0.5. Just as a reminder, we already know that UV coordinates go from 0, 0 top left to 1, 1 bottom right. So if we want 0, 0 origin in the center, we need to subtract 0.5 from both coordinates. And finally, since this is not a square, we need to fix the aspect ratio. So UVX would be multiplied by resolution X divided by resolution Y. Here it is. And of course, we want to display something. So let's define our color of the particular fragment, which would start as a black color, and assign it to the internal variable color in capital letters, vector 4, color, and alpha value is 1. Okay. Since the algorithm for creating the fireworks will be a bit more complex in the final stage, we will separate it into a new function to keep our code well organized and readable. We'll name it firework and pass only the UV coordinates of the current pixel as parameter for now. So let's do it right here. It would return vec3 because we want to return a color of the particular fragment or pixel. Firework. And as I said, the input parameter would be the UV coordinates. Okay, and let's start with black color again, which would be then modified by the algorithm to get the right color of the fireworks effect. So our effect should start at some position from which the sparks will be fired in different directions, as is expected from fireworks. For now, we'll set a position to the 0 vector, which will of course improve later. So vec2 position would be vector 2, 0. And we will pass this position along with the UV coordinates to another function called spark, which will be responsible for rendering individual particles. Since we expect that there would be more than one particle at once, we'll add a call to this function in a loop. Let's create the loop for float e starts at 1. I mean a particle count. It doesn't exist yet. I will add it shortly. I plus is 1, and or I better add it now so we get rid of this error. So this would be simply a uniform parameter that defines the number of particles per the fireworks effect. That would be uniform float particle count, and let's give it a hint range from 1 particle to, let's say, 50, and the step should be, of course, 1. We don't want half particles or something like that. And the initial value, let's start at 1 to keep it simple. Very well, and as I said, we will call the spark function, and the result of this function should be added to the final color. So color is increased by spark, and it should take parameters UV, position, and the index. By the way, you might have noticed that we usually start indexing from 0, but now I am using 1. The reason is that we will need this value in calculations and multiplications mostly. So if we multiply by 0, the result would be 0 again, black color. We don't want that, so that's why we started at 1 right here. And what we need now is to define the skeleton of the spark function. By the way, you might be wondering why I am using float in the loop instead of int, as is customary in other languages. There are two reasons. Firstly, it is known that modern processors and GPUs work more efficiently with float values. And secondly, we will need these values in further calculations, so by declaring them as floats, we will avoid the need for conversion from int to float. Okay, as I said, let's prepare the skeleton of the spark function right away, so that we have the entire structure of our shader in front of us and can easily enhance it. Once we have that, we'll add the call to the fragment function and be ready for improvements. It is also likely that we will want to display fireworks at more than one position, so we'll enclose the call to the firework function. I will enclose this call from this function to that function in a loop as well. We can also use several uniform parameters to define the number of fireworks and sparks. Actually, we already have the number of sparks, particles right here, so let's add another one that would control the number of fireworks. Copy and paste this line. What did I do? Damn it. Sorry. And rename this as firework. Okay, and again we will start at 1 firework and 1 particle to keep it simple and explain everything slowly. All right, so as I said, let's finally, I know I'm still talking about other things, but now I'll finally do it. Vector 3 spark would take parameters UV coordinate, position of the particular firework effect, and the index, and of course we are declaring function, so we need to specify the types, vector 2, and float. Okay, nice. Very well, and let's just keep it empty for now, so we will simply return 0 vector 3. All right, and now we need to return something from here. We'll be returning the color. And as I said, the whole firework function should be called from the fragment function right here in a cycle for float I from 0 I less than, this time it's a firework count, I plus equals 1, and in this cycle we will add to the color variable the result of the firework function work, and we need to pass UV and the index. Yeah, this is the typo, that's why the autocomplete didn't work. And since we are passing two parameters, we need to fix it right here as well. Float index. Okay, all right. It's time to finally display something, so the spark function would stop returning the 0 vector and instead implement a simple function to create a circular object. Then we'll add some color to it. Let's do it. So let's define the shape of the circular object, and as we know, the circle is easily defined by dividing 1 by length of the UV coordinates, and since we are starting at the position, we must add it to our calculation. Okay, and as I said, we need to color it somehow. Let's separate the color components one by one. So float red would be, we need to use the shape and multiply it by the color value. Let's, for example, start at 0.2. Later we will use a noise function to randomize that, but right now let's keep it simple. Float green would be shape multiplied by, for example, 0.3, and float blue is shape multiplied by 0.6. Alright, and now instead of returning the 0 vector, we will use red, green, blue. Okay, and we can already see something here in the inspector, but it's not exactly what we're looking for, but it's a good start. By the way, I think our particle needs a bit of adjustment. Let's add the parameter size and sharpen and use them in the calculation. First, let's take a look. Yeah, it's a circle, but it's too big and it's just too blurred, so let's do something about that. Uniform parameters right here. Again, we will use full parameters, so we can simply copy, let's do it right, copy and paste twice. First of them would be size, the second one sharpen, and now we will go from 1 to 10 with a step 0.1, so it's smoother, and I think we can start at 2 as the initial value. As for sharpen, we will go from 1 to 10 again, and again the step would be 0.1. We will start at, for example, 1.5. Alright, how we can use them? First, we need size at the shape function, so this would be multiplied by size, and since this is still too big and we would have problems defining too small range in the inspector, it wouldn't be too convenient to use the slider. Let's multiply that by 0.01. Okay, much better. This is starting to look like the particle we will use, in fact. Okay, so this is the size and sharpen. To sharpen something, we can use the power function. Pow, vector 3, and now, since vector 3 is the first argument, we must use vector 3 as the second argument as well. So it will be simply vector 3 and the sharpen value and finish. Yeah, I think the halo is not as visible as before, and we can then work with these values in the inspector to fine-tune that. A static particle wouldn't be very useful. We need to animate it so that after the initial explosion, it follows a parabolic trajectory and eventually disappears from the screen. This will require using the internal variable time and making further adjustments in the code, including adding new uniform parameters. So let's do it. We will add 3 new parameters right here. Copy and paste, paste, paste. First one is speed, just to control the speed, of course, of the effect. It would be again a hint range from 1 to 10 and 0.1 as a step, and I think we can start at 2, so it's not too slow. Second one, gravity. If we don't use gravity in our calculations, the particle would simply follow a straight line, which wouldn't look too natural. So we'll add this and make it from 0.1 to, for example, I don't know, 2. Again, step would be 0.1, and let's start at 0.9. I think that 0.98 is the standard gravity and gravitational constant on Earth. So let's keep it the same or almost the same, and the final one we'll call lifetime, because of course we don't want to display the particles forever. Once they leave the screen, we want to get rid of them so they don't consume more and more resources, and it would be simply optimized for big numbers of simultaneous particles. Okay, so 1, 10, and I think that I've been doing experiments, and 7 seconds was the best value for that. Let's keep it at this. So we will define the life cycle using the modulo function so that it repeats at regular intervals, achieving a continuous effect. Let's do it here in the firework function. So here, float cycle would be, as I say, modulo time multiplied by speed and divided by the lifetime. So each time the time by speed divided by lifetime reaches the maximum value, it would then go back to 0 and repeat over and over, creating this kind of endless fireworks effect, as you could have seen at the beginning of this video. Okay, and since we have the cycle, we need to pass it to our spark function as a new parameter. Let's do it here, and let's add it here, float cycle. All right, now we can use, we have to use this cycle. So we need to, of course, we need to define a direction of the particle being animated. So let's do it here, direction, and at this moment, let's make it constant, I don't know, 0.3, 0.5. And the direction must be controlled by the cycle and the gravity, especially the y coordinate, because the x coordinate, it can be simply driven only by the cycle. Let's do it right here. Direction y would be decreased by cycle multiplied by gravity, and again, to make it more natural, I think I multiplied everything by 0.1. All right. Is that everything? No, it's not. We need to fix the shape as well, because now it must be shifted by the direction multiplied by the cycle to make it animated. Okay. If you take a look at the inspector, you can see that something is happening there. Let me show you. Yeah, the particle is leaving the screen too fast. That's because these values are not the best. Let's try, for example, 0.1 and 0.3 and wait for it. Yeah, now it's better and we can see the parabolic trajectory. Great. So we are done with the basic functionality. The entire fireworks display will actually be based on this principle. Now we need to introduce a pseudo-random element into it so that individual particles have different colors, trajectories and life cycles. We will use the previously used noise function, which returns a pseudo-random vector for each input value. This is necessary because a random number generator is not supported in shaders. I will just copy and paste the function from another source. I have it here. Let's copy and let's paste it here. Okay, simple function, vector2 as the input parameter, vector2 as the return result. Alright, so we have a pseudo-random generator now, and we'll use it in several places within the spark and firework functions. For each instance of a firework and each particle, we will get different values by incorporating the current loop index into the parameter of the noise function. Let's start at the spark function. So the first usage would be right here. We will simply call noise for this vector, and the parameter would be multiplied by index. So it returns different values for each particle we want to use. Alright, and now there's one thing. This noise function always returns a positive number, but we want to shoot these particles not only to the left but to the right as well. So let's do this trick, and half of these values we will reverse the x coordinate. So if modulo index and point and 2 is 0, which means the value is even, we will set direction x to its negative value direction x. Okay, good. This is the first thing, and now we need to randomize or pseudo-randomize the colors. So shape would stay here, but instead of this fixed number, we will use again noise, and we need a vector2 input parameter. So let's make some arbitrary set of numbers, 0.1, 0.2, multiplied by index, and now we need only a float, not the vector. So let's just take the x component. Okay, and we will change the rest in the similar way. Noise, and this time, for example, 0.3 and 0.4, and for the blue component we can use 0.5 and 0.6 as an input parameter for the noise function. Okay, it seems to be already greenish, and which is correct. Okay, this is the spark function, and now the firework. First of all, we need to randomize the position, so it would be again noise of a vector and not 0. I think we can use something like 0.2, 0.4 and multiply that by index. Okay, and let's do the same trick as we did for Spark with this modulo. Let's copy paste, and this time we are reversing the position, not the direction. Alright, and cycle should be randomized as well. Time, speed and lifetime, it remains, but lifetime, let's multiply it by this formula. 1 plus noise, and we need to use some vector again. Let me just try 0.1 and 0.9, and again multiplied by index, and again taking the x coordinate. All right, is that all? I think it is. Yeah, I think that would be all parts of the code we needed to randomize. Okay, and we are done. It probably doesn't look like that, but let's see what happens if we just play with these parameters. Let's start with increasing the particle count. Now we have 4, 5, and I change it to 50. This is a nice firework, isn't it? But only one. Let's make it 2, 3, 4, 5, 10. And change, for example, the sharpening. No, opposite direction. Now the glow is not as glowing as before. Change it back, change size, make it bigger. It can be almost used as an explosion, don't you think? Or speed. It's too fast, let's make it slower. Or faster. Gravity. Let's make it fall faster. Or let's make it fly. Very nice. Okay, I think that's it. Thank you for watching, and if you want to use this shader in your own game, feel free to do so. I will upload the shader code to the site Godot Shaders, so it should be pretty easy to copy and paste it from there. So, take care and see you in the next video.